So in this example, we have these professors' ages, and it states, suppose the following is a list of the ages of professors in the College of Liberal Arts and Sciences at a local university. And we have a list of ages here. Now there are 40 ages listed here, if you count them all up. So we're going to say that their n is equal to 40. And it says here, determine if the data is skewed left, symmetrical, or skewed right. Don't forget that for data to be skewed to the left, the mean has got to be smaller or further to the left than the median. For data to be skewed right, the mean has to be greater than the median or further down the number line to the right. And symmetrical, well, symmetrical, it doesn't favor either one side or the other. So the mean and the median are going to be kind of close to each other. And then, of course, it says construct the histogram of the distribution using a class width of 5. So we're going to first go ahead and create our histogram first, just to see how it would look. And then maybe use the histogram to determine whether the data is skewed to the left, skewed to the right, or symmetrical. So if you recall, the first thing we're going to do in order to make a histogram, the first step is we have to put in our number line. Now our number line goes off into infinity in either direction. We don't need infinity. We only need a certain span. So for that span, our smallest data value here is 29. And our largest data value is a 62. So we're going to start off minimally with a 29, and it's got to go at least up to 62. Don't forget the class width will help determine exactly where it goes, but we have to go to at least 62. So I'm just going to go ahead and draw in a number line here. Now that we have our number line here, the next thing we do, the second step, is we go ahead and we do our class width. Well, we already know that the class width has got to be 5, so we don't have to calculate it. The next step is to go ahead and make the distribution. So we'll do that. I'm going to go ahead and I'm going to put in ages here. How about that? Or age. And then frequency. Now the smallest age, or the lowest age I should say, the youngest age, is 29. That's our smallest data value. So I'm just going to start with 29. Now this is our lower class limit. So then the next lower class limit to the next class, you just add 5. So this is going to be 34. Then you add 5, 39. Add 5, 44. Add 5, 49. Add 5, 54. Add 5, 59. Now since our largest data value is 62, we don't have to go any further because the next one up here would wind up being 64. So we'll stop right here. So then if I go from 29 to 33, 34 to 38, 39 to 43, 44 to 48, 49 to 53, 54 to 58, and then 59 to 63. Then I have to go through my data and see how many values fit each class. So between the ages of 29 and 33, I found that there were 4 of them. Those between the ages of 34 and 38, I found 8. Between the ages of 39 to 43, I found 8. Between 44 and 48, 7. Between the ages of 49 and 53, I found 6. 54 to 58, 3. And 59 to 63, I found 4. So now that we have our frequency distribution here, the final step, step 4, is to go ahead and put in the bars or go ahead and create the histogram. Now the largest we have here is 8. So my frequency here doesn't have to go much higher than 8. So I'll go... How about if I go up to there? Here's 1, 2, 3, 4, 5, 6, 7, and 8. And then we put in our bars. We use the lower class limits, 29 to 34. Well, here's 29 to 34. There were 4. And don't forget the bars are going to touch. Between 34 to 39, there were 8. What about if I do this? (39 to 44), there were 8. (44 to 49), there were 7. Oops, one more. (49 to 54), there were 6. (54 to 59), there were 3. And then, of course, if we were to put in another lower class limit here, that would be 64. So from 59 to 64, there were 4. So here's our histogram that represents this set of data of the professor's ages with a class with a 5. With a class with a 5, we have 1, 2, 3, 4, 5, 6, 7 classes. 1, 2, 3, 4, 5, 6, and 7 classes. And as we look at this data, it doesn't really seem to favor anything. If we were to kind of think of the shape, if we were to put a line over the top of this, it doesn't really seem to skew too much one way or the other, so it kind of looks like it's symmetrical. The argument can be made that it's symmetrical. So the median for this set of data don't forget, the median is a positional thing. If we were to put all this data in numerical order, put it in ascending order, the 40 plus 1 divided by 2 position, that's 41 divided by 2. That would come out to be 20.5. So between the 20th and the 21st position, that would have a median of 43.5 years. Of course, if we add all these up and divide by 40, that'll give us our mean. And our mean comes out to be 44.5 years. So our mean is a little bit larger than our median, so it kind of looks like it's skewing to the right. But I wouldn't necessarily say that. I would say that if anything, it's more symmetrical. So since it's more symmetrical, the mean would be the better measure of central tendency that would describe this data.